Teďka mě slyšíš? Okay. Okay, so we can start. I welcome you all on today's InDeEd session, which is about introduction to MongoDB. For those who doesn't know me, my name is Ondra Kršňák. I'm a full stack developer here at CN for about 2 years now. And today I will tell you something about the database, MongoDB, which I'm using on the project for the last 2 years. So the first thing, what is MongoDB? I guess most of you have some knowledge of databases, probably mostly relational databases, some SQL databases. But MongoDB is completely different. It's a NoSQL document-oriented database, which means that the data are stored in documents, and the document is set in JSON format. In the file system, it's stored in the BSON format, which is like the JSON only binary form. One of the interesting things is documents are schemaless, which means there are no schemas for the data. So every document can have completely different fields, completely different data types. There's no schema for it. There are some limitations that the document can be maximum of 16 megabytes, but MongoDB has some solutions for storing bigger files, even like images and videos, and the solution is called GridFS. Of course, you can communicate with the document server using shell or using some drivers, so you can connect it with from your application to the database. MongoDB itself is for free, so there's nothing stopping you to use it on your pet projects, but there's also the paid enterprise version, which has some enterprise features. Let's say we're using it on quite a large project, and we're using only the free version. It's sufficient for us. And you can run the MongoDB, of course, locally. You can run it in Docker container, or you can run it as a cloud service, which MongoDB offers. I will tell you more at the end. Something about naming. So what you know from the relational database management systems, you've got some databases. The group of some data are in tables. Each entry is a row, and each row has some columns. In MongoDB is completely different. So we are grouping the similar data to collections, and in every collection there are documents, and every document's got some fields. So another example how you can imagine it is you've got, for example, database shop. You've got 2 collections in this case, users and articles, and each of these collections got documents which are the JSON format. In here you can see that, for example, the second document in the user collection got different fields than the first. So as you can see, it's schemaless, so every document can have completely different fields. There is some document example for those who are not aware, for example, how JSON looks like. It's just a big object with key value pairs, where the value can be a string, can be a number, array of any values. It can be even some like embedded documents, embedded object. And I can show you one more thing in here. As I said, you can communicate with the database using some drivers. Here are some official maintained drivers for all kinds of languages. As for example, you cannot see here F#, but if you want to use F# with Mongo, there are some other drivers maintained by community, but not the MongoDB company. So this is not all of the drivers that exists. And there's another example how you can imagine the data. This is the cloud service I will be talking at the end, but I've got some sample data here for you. So in this case, I've got like 6 different databases. If I open one of them, these are the collections, comments, movies, session, theaters, and users. And in here, this is one of the document. If I open it, as you can see, it's got a lot of different data, strings, arrays, integers, some dates, timestamps, and so on. So there's no limitation for you how to structure the data in the document. Any questions about this introduction, basics? Okay. So the next thing we have to think about is data modeling, because the structure of the data is quite different. in comparison to the SQL databases. So one important thing we have to think about is the data are queried frequently together. For example, if you've got some users and they've got some addresses, then in SQL you will like join the tables together, but in here you can embed the addresses into the user document, and you can have all these information in one query. For example, there's an article and name of the author. When you have some block, you've got articles, and in SQL database you will have one table where you've got the information about the article, the text, and there will be probably some author ID, and in another table there will be the ID of the author and the name of the author. So in SQL, to show the detail of the article and show the name of the author, you have to make a join, which is quite a performance expensive operation. But if the user changes its name, it's just a really quick operation, just change the name in one table. But Mongo goes a little bit different way. It's going the way that the most frequent operation should be the quick one. So in this case, you will put the whole name of the author into the document of the article. So in one query, when you're fetching the information about the article, you will also fetch the name of the author. So you don't have to make any joins. But of course, if the user changes its name, you have to go through every article and changes the name individually in each document. So in this case, the operation is quite performance expensive. Another example of how you can imagine the structure of the data in SQL database and how you can transform it into Mongo document. On the left side, you've got some tables which are connected together with some IDs. On the right side is the equivalent document in Mongo. Any questions about this? No.
How it works when I have, for example, eShop, there are like some transactions and this kind of stuff. I want to join them because I'm familiar with the relational database. How it works when I want to like select or create reports about that when I don't have the same attributes as I'm used to it. How do you do that in this way? Like, just don't get how it's possible when you have completely different. I don't know the name. Like normally it's called like columns, yeah, and they are different. How it works when I want to find something like through the select query? How I do that here?
So, for example, how you find some documents?
Yeah, I want to create a report of KPI. I don't know.
Yeah.
Like
about these CRUD operations, how to find, update, insert, and delete. It will be later in this presentation. This part is only how to model the data, how to think about structure.
All right.
Okay. So there are two ways how you can structure data. First is embedding. The second is referencing. So embedding documents is really useful if you've got one-to-one and one-to-n relations. And when you've got one-to-n relations, when you query for the one document, the n documents are queried together with the one. And of course, if you're embedding these documents together, the document can kind of become bigger and bigger, but we have to think about the limit, which is 16 megabytes. And there's example, for example, one-to-one relationship. In a SQL database, you will have two tables. One will be some user and addresses. In here, it's one document where the address will be embedded into the document. So you will just ask for a user with name, Joe Bookreader. You will receive the name and the address for the user. And you've got one-to-n relationship. Then instead, the addresses will not be a simple object, but it will be an array of objects. It's pretty simple, I think. The other option how you can structure data is referencing. It's similar what you know from SQL database when you got some keys. In this case, you must have some identifier. By default is _ID, but you can use any property. And in this case, the connection of the data is not done by the database itself, but you run a query for example, for users, and in the application, you will run a second query for the IDs, of, for example, of addresses. And in your application, you will just connect the data together how you want it. This is really useful for some complex one-to-n and of course M2N relations. For example, you've got a collection of users, the same example as before, and it's got some addresses. And you've got a different collection of addresses, and in the user just only the names of IDs, or it can be anything in the different collection. So your application will first run a query, find me a user with a name Joe Bookreader. You will receive the object on the left in your application, and then you will run a second query, find me in the collection of addresses all the addresses where the ID is street 1 or street 2. And then in your application you will connect them together.
Does it tell me if I don't see the right collection, if I see only the user collection, how do I know that street 1 is referenced somewhere?
You don't.
I don't. Okay.
It's must be managed by the developers. Developers must know what is what.
Really?
Yeah.
I want to start to say.
Like this, it's just some string.
Okay.
And the M2N is the similar, but you've got the IDs on both sides. So the authors got IDs of the books he wrote, and the book have got IDs of the authors has been written.
I mean that this is like document first. It means that all data structure is defined just by data, but there is no like SQL for building for defining structure of data. Like because in SQL you can define like relationships. Of course, this is foreign key.
Yeah.
There can be relationship. These are defined just by data.
Yeah. There are some schemas. I will say a little bit at the end, but you cannot define, like for example, this is a reference to something. You will just say if it's required, what kind of data type should be, but you're not saying anything about the referencing and so on. Okay. Now we get to the CRUD, the create, read, update, and delete. There will be some examples of code. They're all written in JavaScript using the Node.js driver. Get to it. So first of all, you must know the underscore ID must be unique, something like primary key in SQL databases. By default, it's an object ID data type. It's some hash, some long string, which has some information about the timestamp when it was created, some unique part of it, just making the underscore ID unique, and so on. And this underscore ID can be any type you want. So it can be, for example, a string, can be a number, whatever you want. And of course, it's immutable, so you cannot change it when you create the document. You can change it later on. The collections are created automatically, so you don't have to run any create table scripts as you used to in SQL. You will just say, I want to have a collection inventory and insert one document. The MongoDB will try to search for the collection. It's not there, it will create it. A nice feature is the atomicity on document level. So when you have some really big document with a lot of fields and you want to update it, so it will update only all the fields or none of them. It never will happen that you will update like 5 fields will be updated and the rest will not, will remain the old. And really nice feature which will help you to find the data you want. Because when you're reading or updating or deleting, you have to write some query which will find the data. For example, which one you want to read, which one you want to update, or which one you want to delete. So we've got some operators. They all are prefixed with a $sign. And these operators, for example, telling you if the documents have some equal value, something, or greater than, for example, find every article where the price is greater than 1,000 or something. It can, for example, $exist, which will tell you, which will find you only those documents where the field exists, because it's schemaless and not every document can have it. It's similar for update operators. There are some aggregation stages and operators we will see in the aggregation part of this presentation. And there are nice query modifiers, for example, $explain, which will tell you more about the execution plan. If the database is doing some column scan, if it's using some indexes, which index, and so on. So it's really helpful for some debugging when you're trying to find what the database does. Okay, so. Okay, now we will move to the create part. It's really simple. In this case, for example, if you want to insert single document, the DB is the instance of the connection to the database. So you're saying to this database, I want to use collection called inventory and insert one document, and you pass the document as a parameter to the function, which is just JSON. For example, in other languages can be a little bit different. I think in C# we have to create some BSON instance of the document, which you then be inserting and so on. And insert multiple documents, it's completely the same, but you're not passing one document, but you're passing an array of documents. There's one thing you can notice in here. All of these functions, like for even for create, read, update, or delete, the last parameter is some options. In this case, it's the option called ordered false, because what insert many does is it inserts them in the order how they are presented in the array. And in this case, if the first document will fail for some reason and it's not, the Mongo is not able to save it in the database, the second one, it will not even try to save it. But if you say order false, it will try the first one, it failed, and it will continue. And in the response, you will receive how many documents were inserted, you will receive some these IDs of which document were inserted, and so on. So it's up to you to handle it if you've got the order false, to find out which documents are the not valid, where the problem is. Read. So again, you've got some database instance, and you say collection, the name of the collection, and you've got that find, into which you just put a JSON, which somehow is the query of the data. In this case, empty object, it matches every document, so it will return you all the documents in the collection. If you want to specify some condition, in this case, you want to ask for the field size, which is a subdocument, and the subdocument, there's property called age, and the property age must be greater or equal to 10. So if I go back, for example, this one, there's the size, which is subdocument, and there's property age, and it's 7.9, so this document will be selected, this one as well, and this one as well. Important thing, the find method returns a cursor, which is something like pointer, let's say, just pointing at some data. So in this case, the find status D will return you some set of documents, and the pointer is just pointing at the start of this set. Then you can tell the pointer skip first 5 documents, so the pointer just will move to next 5 documents, and then limit the set to only next 20 documents, and the rest will just return me as an array of documents. In other languages can be a little bit different, for example with the toArray method.
We have a question on the slide.
Yeah?
Maybe can you read it because it's complicated for you.
Okay. If you see something like books want to, or authors want to do. I think this is the same question. It was asked here. You don't know if it's some like foreign key or anything. It must be managed by the developer. So you know, just it's some ID, and you need to have some like documentation or something that you know that this property with this value is key to another document in which collection and so on. For example, in this case, it's books 1 and 2, but the collection where you can find the data, they don't even have to be named books. It can be completely different.
This can be managed by Mongoose. Have you tried?
Yes, I've tried it, but I like to Mongo more because it doesn't insert another abstraction layer, so you got more power of what you're doing. Okay, update. The first parameter is again the query, so you trying to search for some data. It's the same query you can use as for the finding the data as before. The second parameter is the set or the update operation. In this case, you are using the set operator, which is telling me that in the document which I find, I want to update the size, unit of measure to centimeters, and status to p. If the field already exists in the document, it will change the value. If the property doesn't exist in the document, it will create it. And the next operator, for example, the current date, when document is updated, the last modified property will be updated to the timestamp when it was updated. So you don't have to inputting some another option, another field when it was last updated, which is created in your application. The MongoDB did do it for you. The update one will update only the first document which will find, which will match the item canvas query condition, and the sort of the document by default is done by the order how it was inserted into the database. The update many will update all the documents which matches the query. In the first example, you can see the options again, which is called upsert true. What it does, it's in this case, it will try to find a document where the item is canvas and update it. But if it don't find it, it will create the document, or a completely new one. So we are using this for some data on our project. When we try to update it, if it's not there, just create it because we need it in the database. The last one is delete. Again, everything is almost the same. So delete one and delete many, you're just inserting one property, in this case for the search query, which will match the documents and it will be deleted. Delete one will again delete only the first one, which will find, and delete many will delete all of them. If you want to delete every document in your collection, you can just pass the empty object. Sometimes deleting all the documents might be better than dropping the whole collection, because if you delete all documents, the indexes, some validation schemas, etc. will remain untouched. It's still there, so just remain everything and then just inserting again, and the indexes still works. Okay, so any question about this CRUD operations? Yes?
Import it again, but probably you must keep your UID. Or if
You mean in this last case?
yeah.
In this case, for example, if you got, for example, a log and you want to delete all documents at the end of the month, you just delete everything.
Mm-hmm.
You don't have to keep any IDs or.
Okay, I understand. So
Depends on the use case.
Okay.
If you want to just delete everything in the collection, but you want to keep the indexes, validation schemas, so you have to create it again, you will just delete all documents and not dropping the whole collection.
Okay, understand. It's just about collection.
Okay. Next one is aggregation. Aggregation is some operation when you just give some set of data, it will do something with it, and it will return you somehow modified the set of data. It can be some group by, for example, and so on.
There's one question about last, but why is indexing if you remove all data? So usually you index data which are, for example, in the table.
Yeah.
So when you remove all data, so why you keep indexing?
Because you can start inserting another data.
Okay.
So at the end of the year, for example, you will delete a whole collection of logs.
Mm-hmm.
And then you start inserting your data, but they're already indexed because the index exists.
Mm-hmm.
You have to create the index again.
Mm-hmm. Okay.
Okay. So yeah, the aggregation. There are 3 types of aggregation, and now we will look at all of them. First one is the single purpose aggregation operations, which is an aggregation methods done by Mongo because they're quite often. So the estimated document count and count documents, they're all similar. The first one will return you all the documents in a collection or a view. The second one will kind of do the same, but we have to pass some query object as we saw before. It will return only the count of the documents. It will match this query. So for example, the second one, if you pass the empty object, it should return the same amount of documents as the first one. And there's the distinct method, where you pass only one string, which is the name of the field. It will return you all the values this field have in the database, in the collection. And all of these methods are on the collection, so as you before used the insert one, insert manify, and now you will use directly the method.
We have the question on the Slack.
Yes, you have to keep it in documentation or where you discuss it with the team. It's really up to you. For example, in our case on the project, we have it in small like wiki page for this for the project where we can keep it. And there's quite small teams, so we know it. But in case of like larger teams, it can make problems that not every developer knows it, of course. Okay, there's the map reuse. MongoDB offers these options. I never used map reuse in Mongo. I use it in other databases, but for you who doesn't know what it is, you've got some set of data, which is the first column, and you will pass first function, which is a query. So in this case, it will match all documents where the status is A. So you got some smaller set. Then you will map it. So just put another function which says the key is the customer ID, and you want to reduce into some value. This is the amount. So you will receive the key is the customer ID and the array of the values. And then the reduce function, in this case, it's making the sum of the values. The map reduce has the same functionality as the aggregation pipeline, which we see on the next slide, but the map reduce has a better performance for this use case. So if you want to use directly this, then the map reduce is better than the aggregation pipeline. But the aggregation pipeline has a lot more options what you can do with it. Okay, so aggregation pipeline is the really powerful thing. In here, you've got some aggregate function on collection where you pass an array of stages. It will go from one to the other. In this case, the first one is sort. There's the $sort, which is the operator for sorting. And I'm passing here a query, which is in the JSON. It's in a variable, so you can see it in the right side. So it will sort the data in the article collection by price. And if the price is the same, then by article number. This sorted data will be passed to another stage, which is the lookup. We'll look at the lookup more closely at the next slide, so just skip it for now. Then it will go to the match stage, where there's some query. So the query is the same as you saw before for the find, for example, method or any other. And the set of the data will be smaller again. And then the skip and limit is, for example, you've got some paging on a page, so first skip first 10 documents, and then the rest of the set just limit to some number. And the project is a nice feature because these documents can be quite huge. So the project, in this case, the right side, you can see it, telling you what fields Mongo should return. So in this case, I'm telling the Mongo the underscore ID should be excluded, and the article number, product name, and description should be included. So in this case, every document will have only 3 properties. When you find this project object, when you set a first property to 1, then you have to name and include all the rest you want, except the underscore ID, which is always included, so you have to specifically exclude it. And at the end, again, just make it to an array. And the lookup. This is something quite a lot you can hear from SQL guys, that Mongo doesn't have a join. So Mongo have a join. It's the left outer join. And in this case, as you saw before, we call this aggregate function on some collection called articles. So in this case, we're telling from which collection to join. This join between the article collection, which was before, and some other collection. For example, stock balance. Local field, which is the field of the collection we are calling, on the article collection. So for example, it can be some article number or something. The foreign field is the collection in the from field, and S is some parameter in which you find the joined data. There's also more advanced version of this lookup, which can allow you to do some matches, so you will limit the data before joining. Okay. Any questions regarding the aggregations? Correct. Okay. So the last thing is the MongoDB Atlas. This is the thing you could see when I was showing you the database in the collection. It is fully managed cloud database by the MongoDB Corporation. What it does, it just creates you some managed database on AWS, Azure, or Google Cloud Platform, and you're just paying for the handling of it and some data and so on. There's of course the free tier for testing. So if you want to test it on your, if you want to try the MongoDB on your own project, there's nothing stopping you. And creating new database takes around like 5 minutes, just 10 clicks, then you just wait a while and you have it. The MongoDB Atlas offers even additional features which the MongoDB itself don't have. For example, full text search, which works that on top of the MongoDB there's also the Apache Lucene, which is doing some full text searching, or there's the data lake, so you can connect it with your storage in AWS. It will search through your CSV files, XML files, and so on, and you can search in these files in the data. So it's a really good thing. So if you want to try Mongo, definitely I recommend you this one. And this was really an introduction, because there's a lot of things that we didn't cover. For example, validations and transactions. As I said, Mongo is schemaless, but you can create a validation. You can create an object which will tell you which properties must be required. There can be some enums, for example, this field must have one of these values, which data type supposed to have, and so on. Of course, you got the transactions, and you got a lot of other things we haven't talked about. So if you're interested in it, just find in documentation. There's quite a lot of resources on this topic. The last part, questions.
If you could compare, when would you recommend using MongoDB over some traditional data?
Why?
In which case would you recommend using MongoDB?
Depends on the data. Depends if the data are a lot of relational. For example, you've got a lot of like employees, you've got some projects, it's really connected together. That's the relational data. If you've got something which is a really document, for example, it can be something like an order in an eShop, just to this at this state of time it was this. We've got individual documents. So in this case, the MongoDB, of course, is better.
There are minimum relations then.
Yeah. So the MongoDB has kind of a possibility to do relations, but it's really limited. So in comparison to SQL, of course.
Comparing to Elastic, I know that the purpose is like different, but still there are some similarities. So with a lot of things you can do with Elastic.
I'm not an expert on Elastic, but I know, for example, the Elastic have more advanced feature, for example, the full text search and so on. But I really don't.
Actually, Elastic is full text database, so it's mainly the purpose is just the. Yeah. But I'm thinking about in case of Mongo, we try to use transaction.
Yeah.
So we find out that we must run Mongo in a replica. That's first like condition. But we missed just like cascades and this kind of things. So and we realized that all this stuff we must do manually in the code, like if we have relationships. So all these relations must be deleted manually. Of course, it is in transaction, it's cool, but you have you do more work with relations. Like
Another thing, there's the Mongoose, which is the object document mapper. As Dan said, it allows you to more things, or more things. It just handles some stuff for you. So, for example, you could define some schemas even before the MongoDB has schemas. So it just allows you more stuff than the MongoDB has.
What do you think? What is like the biggest benefit of Mongo? What do you think? Like, because for example, I can take JSON and save it also in the PostgreSQL. There is ability to save like documents, but of course there probably are not some features like in Mongo. What is like the biggest purpose?
Well, for me, for example, as a JavaScript developer, you're writing in JSON, so something you don't have to learn a completely new language. You have the JSON, just learn only a few features how to make the JSON a little bit different for the query, and then you know how to do anything in a database. So it's really simple. For example, if you do Java or C#, it can be a little bit different because you don't have to know the JSON so much. And using a project, it's quite fast without any problems. Also, our data are a lot like documents, like not so much relational. So, for example, in our stack, we've got Node.js on the backend, which is JavaScript. The front end is in Angular, which is JavaScript, and the MongoDB, which is, let's say, JavaScript. So.
Yeah, but when using Mongo, I think you need to be pretty sure that you have the correct use case because, for example, our project, we have Mongo, but unfortunately it's not the use case because project is running for a few years, and I think it started as a small project, but now it grew up, and we have like a collection of, I don't know, like 50 collections which are strongly connected together. So in every schema you have like 5 references to every one, and it's really nice. So.
Yeah, of course, in this case, the SQL database is much better option.
So I think Mongo is quite cool, but you need to be careful about the use case.
Maybe one of the, for example, disadvantages that you don't have really there's no checking, for example, as you have in SQL, so checking if everything, for example, this cannot be null, or you must have all these fields and so on. But if you want to do some like really quick prototype, in this case, for example, Mongo can be better. So, any other questions?
Yeah, there is like probably a famous question about is there any clear proof that, for example, Mongo is faster because many years ago, all people said, okay, it's faster, but I haven't seen any like proof.
Yeah, in this case, I would just say it depends on data.
Yeah.
If you just have one collection with one data and just searching for it, then again depends on some indexes and so on. But if you, for example, doing one join, then the SQL got better performance because the SQL is like made for joins, not the Mongo. So it's really different on the structure of the data.
This is thanks for simplicity of the database. Yeah.
Because as you saw, for example, in here somewhere, in this case, if you want to query something like this, then the Mongo will probably be faster because it will just do one query and you have the information about the document, about the comments, about the author. But instead you have to do several joins.
And what is behavior of cluster in production, for example, because it's fast because it replies data probably, or how does it work in cluster?
Actually, we are actually not using cluster. We have only one instance for every service. And what I read about it is that, as you said, you've got multiple like instances. And most common use case is, for example, that you're writing data to the master instance, which is replicated to the slaves, and you're reading, for example, from the slaves, so you not overflow the master, and you also know that the data are on all of the slaves at the same time, for example. But I'm not really an expert of this cluster.
Okay, it sounds like separation between write and read nodes.
Yeah.
Thank you.
So, any other question? Okay, so thank you for coming.
On the slide, something?
Okay, one more slide. And there's nothing new.
Actually, there's something typing.
Not anymore.
Consumer.